Welcome to Conversations with STEM, the channel that helps you talk and learn with your children about science, technology, engineering, and math. I'm Molly, and in this video we'll be asking questions as we observe an experiment involving a mysterious soda can. Asking questions is a great way to start an experiment because children become the drivers of the conversation as they notice what's important and question what they don't understand. It's really a way to help them make sense of what's going on in the world around them. Let's start by closely observing the setup of the experiment. Have your child watch how the experiment is begun. Ask your child what they noticed about the experiment. This isn't a trick question. We really want to reinforce the practice of observing details about experiments. The observation should be fairly close to this. There's a soda can, a small amount of water was poured into the can, and the can's being heated. Starting with concrete observations gives us a starting point from which to jump out into the unknown. Having your child make observations checks to make sure they saw the important pieces of the experiment. It can also ground them in what is actually happening from moment to moment, making sure no assumptions are being made. These observations can also be used later as evidence for constructing explanations and arguments. Ask your child what they wonder about the experiment. Some children will be off and running at this point, asking questions about every aspect of the setup. Others might be nervous about asking what they perceive to be wrong questions. In order to encourage students who might be a little more shy, encourage them to record every wondering they have about the experiment thus far. Don't worry about being able to answer these questions, and don't try to have your child answer them right now. When a child is generating questions, we want it to be free-flowing. If we try to have them answer the questions right away, they might begin to avoid questions they don't have answers to or think will be too much effort to answer. The only monitoring I would encourage is to keep your child focused on the experimental setup. So for instance, you might want to redirect if you start to see questions such as, why is the flame blue? Or what's the writing on the can? Those types of questions could take you in interesting directions, but they're not going to help us move forward in this experiment. Ask your child what is inside the can. They'll most likely answer water, which is correct, but we want to take their understanding to a little bit of a deeper level. There's a second substance inside the can we want them to be aware of. If they don't volunteer the second substance right away, ask them what else is inside the can. You can guide the conversation by saying, if the can is partly filled with water, what is the rest filled with? You could also guide them with hints such as, what's all around us right now, or what are you breathing? We want them to understand that there's air inside the can because that will be important later if you choose to have them construct an explanation. Ask your child what they think will happen to the water inside the can. They have the information that the can is on an oven burner, so they may assume the water will be heated, much like a pot or a pan when cooking. If they have alternate predictions, as long as they're within the realm of possibility, the prediction doesn't have to be correct right now. Some children will probably say it will explode, which is a great opportunity to discuss predictions based on evidence. Is an explosion what they think will happen based on what they've observed and what they know to be true? Or is it just what they hope will happen? As you watch the video, encourage your child to voice their observations and questions as they come to mind. Being a scientist is a lot like being a detective. We don't always know what's important, so we need to notice everything. Sometimes people, both children and adults, are afraid to voice an observation or a question because they worry that it's unimportant or irrelevant. The best way to combat this is to first encourage children to voice everything that they believe to be important, and then work through those observations to determine what is the most relevant. As long as the question or observation is genuine, treat it as important. Work through the question out loud. Sometimes simply hearing the question again out loud can cause the child to find an answer. It's happened to me when I have to ask a question of a colleague, and halfway through my question, I stop and say, oh wait, never mind, I figured it out. I'd encourage you, if your child says that, to have them repeat the initial question in its entirety and then the answer they came up with. If you're working with more than one child, the answer might not be clear to others who have the same question. You can also listen for possible misconceptions in the answer that might need to be addressed. Other times, a question could lead to a great investigation. For example, a child might wonder whether the type of can would make a difference to the experiment, and that's a really great question when you think about it. In asking that, they're wondering if the properties of different types of soda cans are the same, and they're also identifying a potential variable in an experiment. And those are both really great thought processes. In addition, listening to the questions and observations children deem important helps us to refocus them if needed. We want children to be focused on the variables of the experiment, which are the flame, the can, the water inside the can, and the air inside the can, and the interactions between them. One or two questions outside those variables is to be expected, but if a significant number of observations fall outside those variables, then the child might not have understood the goal of the activity and might need to be redirected. Pause here and have your child add to their observations. What have they observed happening over the course of the experiment? Before moving on, make sure your child has observed that there is a sound coming from the can. Discuss what that sound could be. Have they heard it before? Could something be happening to the water inside the can? Again, since they can observe the can is on an oven burner, they may be able to make the connection that the water is boiling. If they don't make that connection on their own, ask them to relate the experiment to a pot of water on the stove. It may help them to make the connection without explicitly telling them the water is boiling. You might want to pause for a moment and discuss what it means for water to boil. What is the water doing? It's evaporating or turning from a liquid to a gas. Remember that the practices distinguish asking questions as a way to make sense of the world. The practices can and should flow naturally from one to another. In this video, you'll notice multiple points where you can ask your child what they think is going on. Constructing explanations points out the gaps we still have in our understanding of a concept. Because we're focused on asking questions right now, we want to focus on new questions the explanation may bring up. Originally, there was water and air inside the can. As the water inside the can was heated, it evaporated, turning from a liquid to a gas. It's hard to see, but you might have observed wisps of water vapor at the mouth of the can. The water vapor has filled up the can, pushing out the air. Now there's water and water vapor inside the can. Let's do one last round of observations. Have your child notice what happened to the can. What did they see and hear? An important observation here is the amount of water inside the can after it was placed in the bowl. Was it significantly less than or more than the amount of water initially poured inside the can? Also, many children will observe that the can exploded. Explosions go outwards. Did it actually explode? At this point, your child will most likely have generated a lot more questions as a result of the end of the experiment. What do we do with all of these questions? I'd encourage you to have your child decide where to go next. How could they figure out the answers to their questions? Remember, questions are the springboard into the unknown. They could use them as the beginning of a research project, or the construction of an explanation. What did happen to that can? Or the start of an investigation. So what did happen to the can? When we began, there was a little bit of water and a lot of air inside the can. As the can was heated, the water inside turned from a liquid to a gas, evaporating into water vapor. Since heat rises, the air was pushed out of the can, and the can was filled with water vapor. Right now, the pressure on the inside of the can and the outside of the can are equal. The molecules on the inside of the can pushing out and the molecules on the outside of the can pushing in are at equal strengths. When the can was placed into the bowl of cool water, the vapor inside the can cooled down and condensed very quickly, turning from a gas back into a liquid. Liquids take up less space than gases. When the water vapor condensed, the pressure outside the can became greater than the pressure inside the can, and the can imploded. Why was there so much water in the can at the end? Since the liquid took up less space inside the can after it condensed, a vacuum was created, pulling the water from the bowl inside of the empty space. I hope this video helps you to have a conversation with your child. To continue the conversation, visit the Conversations with STEM website to download an activity about air pressure. Leave a comment below to tell us how your conversation went, and we'll see you next Monday for another Conversation with STEM. Thanks for watching!